In this video, we will examine the basics of measuring voltage, current and resistance using a digital multimeter. Note that other videos in the training series will give you more detailed information on the actual meters. An ohm meter is used to measure resistance. An ohm meter does not function with a circuit connected to a power supply. If you want to measure the resistance of a particular component, you must take it out of the circuit altogether and test it separately. Ensure the multimeter leads are in the sockets for measuring resistance as indicated by the ohm symbol. The black lead always remains in a common socket. Ensure the multimeter dial is set to the ohms range. Place the leads in parallel with the component and the meter will determine the resistance. You may need to adjust the range on the multimeter. The values in the range represent the maximum value that can be determined by the meter. For the most accurate results, you need to select the range value that is above but also closest to the actual resistance value. A voltmeter is used to measure voltage. A voltmeter measures the potential difference between 2 points in a circuit. A voltmeter is connected in parallel between the 2 points where the measurement is made. Voltmeters have very high resistance and hence draw very little current from the circuit. Ensure the multimeter leads are in the sockets for measuring voltage as indicated by the voltage symbol. The black lead always remains in the common socket. Adjust the multimeter dial to measure voltage. Note that there is a different range for measuring DC and AC voltages. The straight line indicates DC, while the sine wave represents AC voltage. In this example, we have set up to a DC power supply, so we need to use the DC range. Place the leads in parallel with the component and the meter will determine the voltage. You may need to adjust the range on the multimeter. The values in the range represent the maximum values that can be determined by the meter. For the most accurate results, you need to select the range value that is above, but also close to the actual value. Current is measured with an ammeter. To measure current, the circuit must be broken to allow the ammeter to be connected in series to ensure all the current flows through the device. As a result, it tends to be harder for students to measure current as opposed to measuring voltage or resistance. Ammeters have very low resistance and therefore inclusion of an ammeter into the circuit does not alter the operation of the circuit. Ensure the multimeter leads are in the sockets for measuring current. Note that there is more than one socket. As a result, you must be aware of the amount of current you are measuring. For most of the circuits you build, you will most likely be dealing with current in the milliamp range. Once again, the black lead remains in the common socket. Begin by breaking the circuit to allow the multimeter to be connected in series. We do this because we want all the current to flow through the meter. If we place the meter in parallel, the current would have more than one path to travel, and therefore all of the current would not flow through the meter. Looking at the example circuit shown, you can observe that the meter is in series, because there is only one path for the current to flow through. Once the meter has been placed in series, you need to adjust the dial on the multimeter. Note that there is a current range for AC and DC. The straight line represents DC, while the sine wave represents AC. The example circuit is a DC circuit, therefore the meter must be in the DC range. The values on the meter show the maximum current that can be read. Be very careful when swapping from the amp and milliamp ranges, as the red lead must be changed accordingly.